Water-specific heat capacity is due to the hydrogen bonds between water molecules. This is because of the way a water molecule is arranged, with the hydrogens being at one end, making one end more positive, and with the oxygen and this red area more negative. So essentially what this does is it makes it so that these hydrogen molecules, when they see other, well, not see, they're atoms, when they meet other water molecules, are more attracted to the negative end of them, and hence water can manipulate itself into the shape we most know it as, which is a liquid. So when heat is added to water, what happens is these bonds absorb the heat, and as such these molecules become excited. And when these molecules become excited, or in other words filled with energy, they begin to move. Now when they move, they disperse energy, and this returns them to their original state. So just to compare, water's specific heat capacity is 4.186 joules over grams kelvins. Ethyl alcohols is, and ethyl alcohol would be kind of like a spirit that you would drink. Well, not us because we're high school students. Ethyl alcohols is 2.3 joules over grams kelvins. Gasoline, the stuff you put in your car, is 2.22 joules over grams kelvins. And mercury, that stuff that you're never going to touch or else you're going to burn a hole through your hand, is 0.14 joules over grams kelvins. Water-specific heat capacity is especially important for maintaining the equilibrium of the Earth. Now, because the Earth is made of 70% water and around 29-28% something land, a lot of the heat, when it comes to the Earth, is soaked up by this water. Now, if there wasn't as much water, then all that heat would be dispersed around the land, and land would essentially become overheated and not be able to support life as efficiently. So what water does is it kind of acts like a buffer in this case. And this is especially important for aquatic biomes, where we have ocean life here. Now, if it wasn't for the fact that water kind of does this shifting around of heat, then aquatic biomes would become too hot and they wouldn't be able to support life. So what's a big problem right now is the bleaching of the coral reef, and that's essentially because there's too much heat coming into the water, which is essentially killing off all the coral. Water is also extremely important on a molecular level. Now, the human body is made up of, well, anywhere from 40 to 70% water. And what water does in the body is it keeps the body temperature from fluctuating too much. Otherwise, enzymes, which are important for protein synthesis, would not work. So this is kind of why when you're sick and you have a fever, the doctor or your mom or dad will tell you to take an Advil. This is because it will lower your body temperature and it will allow enzymes, which, as the body codes for defense enzymes, would expedite your recovery, would be actually expedited in their own production, and hence you would get better sooner.